Hello everyone, my name is Matija Domen, and today with my colleagues Marko Kolođera and Lucia Yusuf, we will talk about the implementation of COVID-19 analysis using Exasol, Python, and Yellowfin. This is the agenda of our presentation. First, we will talk something about the motivation for the project. Then we talk about the data sources that we used in this project, about Exasol as a database that we used, Yellowfin as a reporting tool that we used in this project, and in the end we will conclude with a few sentences about the whole project. The motivation. During the lockdown, we got an idea to create a simple COVID-19 business intelligence solution. So as you can know, a lot of data today is on web, so you can use them for your analytics, for data processing, data warehousing, and etc. Also, the motivation for this project was to integrate new technologies and techniques like web scraping, data warehouse modeling, and reporting creation. Technologies that we used were Exasol as a data warehouse solution, Python as ETL solution, and Yellowfin as BI solution. So this is the picture of our architecture of our solution. As you can see, we scrape the data from different kinds of APIs. We scrape them with Exasol UDF scripts. Also in Exasol database, we create views for putting data into the star schema. And in the end, we used Yellowfin reporting tool to create some dashboards, mobile reports, and signals. Data sources. As I mentioned before, we use different kinds of APIs for extraction for data. This is the link that you can see for COVID-19 data for Croatia, and also the second one is a link for COVID-19 worldwide data. Also, it's important to mention that those data are in JSON format. On the left picture, you can see the JSON for Croatia, or JSON for COVID-19 Croatia data. On this data, you can see some numbers of infected, numbers of dead for particular province in Croatia and for particular date. On the right side, you can see just a part of huge JSON that presents number of confirmed deaths and recovered for Croatia in particular day. As a target, we used Exasol database. The Exasol is self-optimized database. Also, it's in-memory analytical database. When we say self-optimized, it stands for some algorithms that optimize the queries in a database, so you don't need to take care about indexes and similar things. And also, when we talk about in-memory database, you know that it's very fast. SQL editors that we used dbbeaver 7.0 and DB Visuals there, but we prefer to use dbbeaver because it's open source too. When we found the data on the net that we want to extract, we try to think how to get the data into the database. So first we thought about approach one. It's a classic one when we used API and some Python scripts, server scripts, and put them into the Exasol database. But when we explore Exasol, when we explore the database, Um, so we used some of the UDEF's Python scripts as some advanced Exasol functionalities. So why not to try something new? Why not to learn something new? So we choose the approach to. What is Exasol UDF? Exasol UDF or Exasol user-defined function is ability to program your own analysis, processing, and generation functions and execute them in parallel inside the Exasol cluster. It can do everything that it can do SQL, plus some different programming languages functionalities. Supported languages for Exasol UDF are Java, Lua, R, and Python. You can use them as some kind of replacement for PLS SQL procedures, and for that, it's recommended to use Lua language. As I mentioned before, we used UDF Python scripts in this project. Python version is 3 and higher, and also there are some packages in Exasol that are embedded, like Redis. It's a connector to Redis database. Both is a connector for Amazon Web Services. Pandas is a package for manipulation the data in Python. NumPy for some analytics and mathematics operations. Request is used for web scraping, and PyExasol is a package for connecting one Exasol database to another Exasol database. This is the example of one UDEF script that we wrote in this project. As you can see, it's the definition is similar as the PL SQL procedures. It's also important to mention that the body of the script is written under the run function with argument of CTX. So this is the example of script that gets all countries, data from all countries. You can see that we imported pandas library, and in the last row of line of this script, you can see the emit function that presents the data that we get. After we collect the data into the database, we start to think how to present them. And one of the idea was to present the data by the province of Croatia. So we need to import some spatial data. Spatial data is geolocation data for representing data on maps. Exasol data type for spatial data is geometry. It includes polygons and multi-polygons. So when we when we get the spatial data, we use also some transformation scripts for converting GeoJSON data to geometry data type. And this is the example how the spatial data looks in the Beaver. So it presents the province of Croatia. And you can see the geodata can be polygons and multi-polygons. That's all for me. And now the colleague Marco will continue talk something about Yellowfin and BI solution.
Hello, I would like to now continue with the representing Yellowfin BI tools. There. What is Yellowfin? Well, Yellowfin is a relatively new business intelligence tool that enables reporting, creation of dashboards, storyboards, signals, automated data discovery, and data preparation. What's important to note about Yellowfin is that it has over 29,000 customers, over 3 million concurrent users, and it is deployed in more than 75 countries. Also, it caters to a wide range of industries, from finance, retail, manufacturing, basically any industry that uses business intelligence tools, and that is almost any industry today. Also, it has been named as it's been positioned as a visionary in Gartner Magic Quadrant in 2020, in January 2020, which puts it as one of the leading companies that can serve any BI need that you may require. What we would like to highlight about Yellowfin are its integrated ETL component that enables us to transform data from within Yellowfin tools without need for third-party ETL tools. It also has signals that enable reporting from, well, not exactly reporting, but it enables mobile awareness, I would like to call it, of your data. It enables collaboration within reports and within dashboards. And it also has integrated artificial intelligence. There are several things we would that we will also mention, but these are the most important things that we'd like to highlight. Now, Yellowfin has several components that we would like to present to you. First is data source connectors. Yellowfin has a wide variety of database connectors that can connect to any modern database that is widely used, such as Postgres, DB2, Oracle, Exasol. There are also several other options available if your database is not supported. One is to build your own connector and then deploy it on Yellowfin. And second is to discuss the certification of your database with Yellowfin itself. And third is to use pre-built connectors that come from Yellowfin Marketplace. Next step we have is data transformation. This is a tool that enables us to transform data from data source into view, into usable view that can be then read by Yellowfin. View is basically a metadata layer in which we define relationships between database objects, usually views or tables, and we implement additional business logic in it. And then we can use views as base for reports, dashboard stories, and other components. Additionally, aside from using views, we can, if using view is not feasible for any reason, we can create our own freehand SQL and use it directly in reports. This way, we can basically run around the views and directly use it on reports. After creation of views, we can now create reports, and we can create signals directly from views or from reports depending on our need. And in creation of reports, we can then we combine multiple reports into dashboards, stories, and presentations. Additionally, we have timeline, which enables us to see the changes, to track changes through time. Next, we would like to demonstrate a simple creation of view. It all begins with selection of data source. Data source, in our case, we have as we previously explained, we have used Exasol as data source. After selecting data source, we have on the left we have list of available database tables, and using simple drag and drop, we can transfer tables that we wish to use in our view in canvas in the view canvas. Next, by clicking this icon, we can create connections between tables. Here our tables are called have simple names that we use notation that distinguishes dimensions from facts. We can and in bottom part we can choose which field is connected to which field from dimension to fact, and we can decide which join type and which cardinality is then used. After that, next step is defining what we will need from certain table. There are several options that are available to us. First is metadata. Here we can decide what the display name of our table would be. This is very useful if we have several dates that are used in fact tables and only one date table, which is usually the case in all data warehouses. This way we can rename a certain table to suit our needs, and then differentiate which table is used for which field. After that, we have the columns pull-down menu, where we select which of the columns are needed for our view. This can be changed at any point. There is one caveat, and that is if a certain report is using the certain field, we cannot remove it from the view, which is quite logical. And finally, we have conditions where we can define if dimension tables or fact tables should be filtered by any logic. That's in our business. After that, we go to the next step, which is preparation of view. Here we can see what kind of data is available. It is immediate check that shows us if we have correctly joined all tables, and if we have applied all the filters, and we can decide, and we can check if we have selected all the necessary fields. Now, as my colleague Matic has previously mentioned, we have special the geolocation data needs special attention because of its unique format and a unique way it's presented. So here we will display how we handle that conversion to Yellowfin, so that Yellowfin can recognize data as a geometry. It's a simple step to select which field. In this case, we have selected field ISO2, and then we have applied WKT geometry field, and it's very simple way to display to implement geolocation logic, and it is immediately obvious that geopoint is now is actually recognized as a geopoint as a geopoint data. On top of that, we have additional formatting available for each field, ranging from the display name that we can change to suit our business needs. As you most know, as you probably know, database column names are not exactly suitable for presenting in data in reports. So in this way, we can change the names of our columns to suit report needs, and to be able, and this way we are able to display column names that are recognizable to end users. As well, we can change format, and then even at this point we can change different formatting depending on our needs. And finally, we have the publish option, where we if we're satisfied, we can then deploy our view to be used as a basis for reports. Now, here we can choose which folder and which subfolder will this view be saved, and in such way we can organize our views either on some by business areas or by technical areas, depending on your needs. This here will now display some what we have developed for the COVID-19 analysis. Unfortunately, it's Croatian, but functionality is quite similar for all languages. First, by using the charts, charts are interactive, which means that if we paint cursor along the geofields, we will immediately get tooltips that display relevant values that we have defined in the report. And on top of that, we can use drill downs, which we will demonstrate in a couple of slides later. We will just like to show you where can this drill through be implemented. It can be implemented either in tables or in charts, and we will demonstrate that later. Here we have simple line charts that are also interactive. By that we mean if we use cursor and then move along the values in the chart, we will display either a single value, or if we move slightly along the axis, we will display all the values that are relevant for that data data point. Next, here we will demonstrate the use of a drill through in the chart. This is a heat map, which displays values along the for each day, and by clicking on each of these rectangles, pardon, we will this little pop-up will display, and it will immediately take us to drill through report, which usually displays detailed data about selected data point from previous slide. Next, we would like to tell you something about signals and about how they're implemented and what do they actually mean. Signals are basically notifications that are sent either to your Yellowfin mobile app, your mail, or your timeline. How on what are these signals based? They're based on three analysis. One is that outliers, which is basically the values that are significantly outside of normal range of your data. This can be useful if, for example, during the sales, you notice that certain items are now suddenly spiking in sales. For example, during the recent rush to the supermarkets in March and April, a great example would be when people bought large amounts of meat that are way beyond normal range of sales. Then we have period comparisons, which can then, which as name implies, display changes through time, through similar time, but a year ago, or whatever, or if you have if you need month to month period comparisons, it can be also defined. But it's important to note here that you can define your own periods, and then signals compare values between two periods of your definition. And finally, we have trend changes or volatility changes, which can display warning when trend changes from upwards or downwards, depending on how the values move through time within period, within last week, last month, or last year, depending on your business needs. This is example of outlier where we have detected changes on 9th of May that where active cases of coronavirus has spiked much more than in the last previous 7 days. And this is an example of signal that has been received on the mobile app, Yellowfin mobile app. In here, we now have definitions for other trend changes, where we have defined. Well, to tell the story about this, when we started this project, we first created reports, and then we tracked numbers of active cases, of confirmed cases, recovered cases through reports. Then we combined several reports into dashboards so we can easily process larger amounts of visual data. And then we have decided to configure signals to track changes that are only very important. As a situation stabilized, it was no longer necessary to track changes daily. Just when certain large changes happened, we wanted to be aware of them. This is a case where we have where trend changed for confirmed cases in one of creation provinces, and it means that basically that the change has the number of confirmed cases did not rise as steadily as before. Rather, the trend became less volatile and the curve flattened. And in the outlier case, we have, that would be this part. Outlier case would displays what happened when number of confirmed cases has decreased in very large proportion. And these signals were all received in our mobile app. By clicking the Explore button, we can then track detailed changes, and immediately chart is generated where a signal is explained in a greater detail, along with historical signals that were generated for that data point. Also, also Yellowfin enables discussion, which discussion type, which we have not yet implemented due to time constraints, but it enables users to comment on certain parts of reports and signals and dashboards, and that enables us to more easily more easily track what's important and focus discussion on which data is changing and why, and the importance of the change. Okay. And now I would like to give my colleague Lucia to. I would like to continue. I would like Lucia to continue the explanation of Assistant Insights and take over the presentation.
Thank you, Marko. Okay, hopefully you can all see my screen. So now we are going to show some advanced functionalities that Yellowfin contains. Here we can again see the data set containing data for coronavirus. There is a functionality called Insight Wizard that has an option to describe variables in the data set. So the metric we want to describe is, in this case, the number of confirmed cases. Here we have an option to annotate the context of high values, whether high values are good or bad. In this case, we choose bad values, bad, because a large number of variable confirmed cases is obviously a bad thing. After that, Yellowfin performs an analysis and generates charts. So when it's done, the new window opens on the right, and there we can see the analysis. For example, here we can see that this analysis shows us that the variable deaths most impacts variable confirmed. It also shows us ranges of both variables and the type of correlation between them. This analysis also gives us the second and the third most significant variables that impact variable confirmed, as well as the combinations of two variables that combined together most impact variable confirmed. It is important to mention that this data set is not the greatest solution for showing this type of analysis, because some of the results are more than obvious. But the main purpose was to present you this functionality and to show you the way it works. And this functionality can be useful when you have bigger data set with lots of columns and lots of variables, and you want to have some kind of insight into your data at the start, and it can help you to determine some kind of direction of your further analysis. Okay. Yellowfin also contains some advanced functions, and one of them is forecast. On the graph, you can see the number of confirmed cases in Croatia until the 24th of May. And let's say we want to forecast the future values of numbers of confirmed cases in Croatia. To do so, we click on the forecast in the functions section, and drag it under the variable we want to forecast. Okay, and here we can see the result. The dashed blue line is forecasted value for the period of 1 month, which is the default value. And the blue area is the 95% confidence interval. The method Yellowfin used to forecast this is auto-trend. We have an option to choose between several other methods like simple exponential smoothing, double exponential smoothing, triple exponential smoothing, and moving average. And those are all methods used in time series analysis. But let's say we want to change some default parameters of our forecast. For example, let's say we want to see the forecast for the next 7 days. To do so, we have to click on the settings, and then under the function section on the bottom, we choose the option to manually set parameters. So here we can see that we are able to specify the number of periods into the future this function should forecast. We can also choose whether or not to display prediction intervals. We can choose what kind of confidence interval will be displayed or not to display it at all. And we have the option to display only forecasted values, that blue dashed line we saw earlier. We have already said that we want to see the forecast for the next 7 days. So we specify that number under the periods forward section. Here we can see the results, the forecast for 7 days ahead, starting 25th of May. For example, we can see that the forecast for the 25th of the May was 2,245 confirmed cases in Croatia. Just for the comparison, the actual value was 2,244. So of confirmed cases in Croatia. So the forecast in this case was pretty accurate, but again, this data is very ungrateful for making any forecasts. But however, this functionality can be very useful for, let's say, more stable data with less noise. So the models or the functions we have seen before are some simple time series models. But if we want to use more advanced machine learning and deep learning techniques, there is an option to write your custom models and use it in Yellowfin. Yellowfin is integrated with R, and scripts created in R can be later called in Yellowfin. Also, there is an integration with different types of H2O models. H2O is a platform for, let's say, automatic machine learning. You don't have to have programming skills to run models in the H2O. There are lots of models in the H2O by default. You just have to click and set some parameters, and how H2O does the rest of the job, and it is integrated with Yellowfin, so you can use those models in Yellowfin. Okay, Matija. Matija, we cannot hear you. You have unmute yourself.
Sorry. To conclude this presentation, as you can see, we successfully integrated some web scraping techniques into BI solution. We used web data, some Exasol Python scripts and Yellowfin to present the data. Hopefully you like it. Also, if you have some questions, please don't be shy, ask us, and hopefully we will give you the demand answer for your question. Thank you very much for this presentation.